Hello, and welcome to our presentation on the beginning of surface area. If you haven't done the do now in the Google Classroom, please go back on and do it then. Today we're going to be identifying 6 figures in 3 dimensions. The ones that we're going to be looking at specifically are rectangular prism, cube, triangular prism, a cone, a cylinder, and a pyramid. We're going to be working mainly with Edpuzzle today. That's your assignment. And we're going to be looking at it in those figures. Now, some of those look familiar to you. I understand that. But we're not going to be looking at them in volume. We're going to be looking at them with surface area, because our standard today is surface area. So any relearnings or reassessments need to be completed by May 5th for our test. I want to make sure that I get that in for you. So any relearnings and reassessments need to be completed by May 5th. The test is the grades are in the PowerSchool gradebook. As I said, it's the standard for surface area. Okay, so what is surface area? So we're going to be looking at basically keeping in mind this picture down in the corner where we're going to be talking about like wrapping paper. So today, this definition of surface area is the amount of material it would take to cover a 3-dimensional figure. Now, we do this all the time when we wrap things up for birthdays and for Christmas. So we're talking about, now basically we're talking about the wrapping paper around the outside. So we're not concerned as much with the inside as we're concerned with the outside. It's the area of everything on the outside of our figure. And then the units for surface area are in square units, as we would for area of a regular figure. Now we're expanding the idea to a 3D figure. And we're talking about how much wrapping paper it would take to cover our figure. Okay, so we're looking at looking at 6 basic figures in 3 dimensionals. The first basic figure we're going to be talking about is rectangular prism, and we're going to be talking about that with our second in cube. We also are going to be talking about the triangular prism. So we're going to be doing this with little videos, and the videos will be uploaded into my YouTube channel, where, all good YouTubers go. And the YouTube channel is, it's under the name Maureen Norton. You can pull those things up there, as with this presentation will be there outside of Edpuzzle if you want to look at it again. So in here, I put little snippet videos about each of the different figures so that you can see them opened and closed, which is really, really helpful for surface area. So I'm going to be looking at these videos in here so that you can open and close them and the program is in GeoGebra. So the GeoGebra activities are there, so you can play around with them if you need to as well. So here's the first one. In this little video, we're going to be looking at a cube. So we're going to be, a cube is a figure that has the length and the width and the height of the figure are all exactly the same. So when we're doing this, we can see that we have a 3-dimensional figure right here of a cube. So I'm going to open this up with this program, and you can see that we know with a cube there are 6 sides. So you can see that we're putting these 6 sides together, and this is called a net that we just did. We just kind of unfolded our figure. Today we're going to be, at some point we're going to be creating the nets, but right now we're just looking at it. So you can see that you have the front and the back. You also have the right and the left, the bottom, and then this other white is the top. And so everything is, they're all perfect squares, and then the squares all come together. So the big part about the cube is that the sides are all identical. They're all identical. So we can change this and we can put this back together in here. So if we were to make the length 5 and the width 5 and the height 5, we can do the same thing. It keeps everything the same, or we can go and put it down to 1 right here. And you see that we have our what's called our unit cube. So when we put this all back together, we have our little itty bitty one that we've been using for our volume. So we've been calling this a cube because it is, but you can expand it out and you can make it as big as you need to do. So here we're going to put it out to 7, and then we have to 7 here and 7. And you can see that all the sides are the same. If one of these is different, let's say we take this height and we bring it down to 4, we are now into a rectangular prism. We're now into a rectangular prism. And we can change this length and this width and this height to different values, and that creates different figures for our rectangular prism. So when we open it up here, we still have a left, a right, a back, a front, a bottom, and a top. So the difference between a rectangular prism and a cube, rectangular prism has the length, width, and height are different. 2 can be the same, but all 3 are not the same. But as you can see, when we open them up and lay them flat, we have the same figures in here. So we can put this all back together because we're going to be just working on this. We have our rectangular prism. We can make this down to 1. And that's our first layer when we were doing our volumes. But when they're all the same, they're a cube. So we have a cube and a rectangular prism. Thank you.
Okay, so I'm hoping that'll help, and then you can take a look at that. And then when you want to go into the program, when we're getting into surface area, you can look at these different videos. So here's for a triangular prism.
Here we have our triangular prism. Now we've been talking about this in our volume unit, but now we're going to be looking at the sides that we have of it, our triangular prism. So we have we have a base of our triangle, which is right here, down here at the bottom. We have the height of our triangle, and the height of our triangle is right here. Because this is not a right triangle, we need to make a perpendicular line, and this one kind of drops down different. You can see it visually, but we're not going to get into that right now. We're just looking at that. And then we have the height of our prism, which is right here. So a prism tells us that we have a height here. So I'm going to open this up. When we look at it, we're going to be looking at each of the individual sides. We're going to open this up, and you can see that when we're looking at in here, that this has 2 triangles on it, but then it has 3 other shapes. So when we open this up, we create a composite figure. But we're going to, when we open them up, it's called making a net. But we're just looking at this right here and exploring what our rectangular prism looks like. So I'm going to open this up here, and I'm going to change the height of our prism. We change the height of our prism. You can see that we adjust it, but does not change our height of our triangles because we're not adjusting the base. Here, I'm going to put this real drastic so we can see what they look like. The height of the triangle is we're going to make those points here, but you notice what else happens. It changes our side lengths. Then I'm going to close this up so you can see what we're looking at in here is that the height, but when we change our point here, it forces this rectangle on the side to adjust as well. This is a little tricky to see, so I'm going to make this a little bit smaller so you can see what I'm talking about. We have to, when we change the height, it adjusts it back and forth. Changing the height of the triangle, look at what happens. It makes it shorter and it makes it taller. So what happens here is we change this value on our side. But when we open it up, you can see that our side lengths, the two rectangles, our right and our left, are identical. The front and the back of our rectangular prism are also identical. And then the base, or the bottom of our rectangular prism, our triangular prism is a different measure. So we have 1, 2, 3, 4, 5 different shapes. The front and the back are triangles for our triangular prism, and they're always identical. And the right and the left and the right are always the same.
Okay, so you get where we're going with this. We're making them flat so that we can put them as composite figures. But right now we're just identifying and getting our names together. So if someone were to say to you, this is a cube or this is a triangular prism, you can you know what we're talking about. All right, so a cylinder. A cylinder is a curved surface, and it has a congruent parallel bases that are circles. Now we know this because we've been working with this before, but now we're going to take a look at this and see them unwrapped.
Okay, this is a cylinder. We've been using this in the volume unit, but we know that the bottom is a circle, the top is a circle, and we should know that the top and the bottom are the same. But what happens when we open this up? So we need to open this up and take a look at what happens. And it's really interesting. So because we have a round surface, again, we're looking at our radius. And then this right here is our height. So this going down to the center, and we know that that is a perpendicular value. So in here, this is a right angle. But importantly enough, this height and this height are the same. So that's just a little bit of a preview of what we're going in here. But more importantly, we want to look at what happens when we open it up. So we have a top and a bottom that are the same. And notice what happened to that center. It becomes a rectangle. So it's almost like we take a piece of paper and we fold it around our pan, or making it round like we're going to yell through it like a tube. You see that when we unroll it, it is a rectangle, but when we put it together, we have a top and a bottom that are a circle, and the net shows that we are looking at a rectangle in the middle, which is going to be helpful to us, okay? So this is a cylinder. Okay, so noticing there are differences in our sections in there, we know that a cylinder is similar to a prism, and the bottom and the top are the same. And now we can see that we have our circles on the bottom and the top. So now we're going to take a look at a cone. A cone is a space figure with a circle as a bottom, and the sides are curved, and they all come to a point. Okay, this is a cone. So we are going to know a few things about the cone. If you look at this, this is our bottom of our cone. Now we know cones from ice cream cone. And we're going to think about this as a waffle cone. So we're taking a waffle cone in here, and we are looking at the opening at the top where we put our ice cream is round. So the bottom part is curved. So this whole thing is curved. So we need, whenever we do round or curved surfaces, we always think about radius. So our radius is right here. So we're going to make it real big or real small, but our radius is here. But notice that we're looking at this height right here, the depth of our cone, how much ice cream we can put in there. We always have a right angle. So we need that at a right angle. We can make this tall or small. We can do all different things. So what happens, and this is what's called a slant height, and there's all this other parts in here, but we're really just looking at the radius and the height. But interestingly enough, when we open this up, there's our top. We have our circle at the top, and we have in here our almost a semicircle. Not quite, but pretty close. So I'm going to make that radius a little smaller so you can see what we're looking at. But notice what happens when we change the height. Only there's like trying to put those in there, it changes our value on what we have in our height with our sections. This is a really nice part in here. So we're looking at here is our cone. So we need to know there's a couple things that we're going to be concentrating on here. And you're like, how are we going to do this? Well, we're looking at it in terms of the fact that they are both round surfaces. So the top of our cone is round, and the part we put our ice cream in, the sides up here are also round. So it's one of those things that we need to be aware of when we're looking at a cone. So the top part would be, so if we were to put another figure on top of it, we could put a cylinder or a sphere or something like that, but it's all round in here. So we'll be using, with these values in here, we'll have to be using our pi value. So this is a cone.
Okay. And with the cone, there'll be a formula that you'll be asked to use, and putting all this together. It's not necessarily a composite figure. We'll have to take a look at that individually. But right now, we're just identifying that a cone is round and the sides are curved. So looking at our next one, we're going to be looking at a pyramid. A pyramid is exactly what you think it looks like. It looks like what the Egyptians put together. The difference with this is that the base is a polygon. It's not a circle. If it were a circle, it would be a cone, but the base is a polygon, and then each of the sides are triangles.
Okay, this is a pyramid that we have right here. Its base is a polygon. It can be a triangle, it can be a square, it can be a 12-sided figure. But the big thing about the pyramid is that it comes to a point at the top. So we can change our height in here. We can make it taller or smaller. And we have a base. It can be changed in here. It can be made smaller or bigger. But the big thing, especially in the one that we have right here, is the base is a square. So when we open this up, like we've done with the others with the net, you notice that we have 4 triangles. So this is our back and our front, where we have our right and we have our left. Now, because this is a square that I'm showing you right here, all the side lengths right here are the same. Therefore, the area of all 4 triangles are the same. It doesn't always happen that way, but it does often in order for it to come to a complete point at the top where all the sides match up. So we have 4 sides on the bottom, and so when we open this up, we have 4 triangles. We can also have in here where the base is a triangle. It doesn't always have to be a square. It doesn't always have to be the same size, but what happens is that we do have to have them come to a complete point. All of them match up at the top. So when I open this up, we have a 3-sided figure on the bottom, and we open it up. We have 3 triangles on the sides. So we can have all different values on here. We could have a 12-sided, we could have a 15-sided, whatever it is. It doesn't always have to be where all the sides are the same, but it has to be so that they come to a complete point at the top. Nothing can hang over here at the top. So when we're going to be mainly dealing with square and rectangle bases, that's the ones that are the most stable in a society. You know, you can put other ones out there, if we were to think about the Egyptians, they have a square base. So we're going to be looking at this as we open it up, and that we have 4 triangles that come on our four-sided base.
Okay, so you get what the pyramid has. It has triangle sides and it has a polygon as a base. The last one we're looking at right here is a sphere, and a sphere is pretty complicated for as it is to wrap, as it is to we would have for to wrap a ball is very difficult. But there is a formula that goes around with the surface area of a sphere, and if we need to do that, or if we need to use the formula, the formula will be given to us. And we won't be using the sphere very often, but we do need to know that there is a specific formula for the surface area. And we know that the space for a sphere is that we have all curved surfaces and no base. And that's a very important part of sphere. And we know that because we have a curved surface, we're using pi. Okay, all GeoGebra activities will be uploaded into the Google Classroom, as well as all the little videos, and this presentation without Edpuzzle will be in the YouTube section. And that's it. Thanks.